In this video, we're going to do, we're still on complex numbers, but we're going to do exam questions, practice exam questions that you need to be able to do. So before I attempt the question, you could just pause the video, try to do the problem on your own, and then play it on to see if you were on the right direction. So we have a problem here, of which is almost summarize everything that I've dealt with on the two introduction videos, of which was just an introduction to complex, addition, subtraction, division, and multiplication for the first one, and the second was, you need to check all those videos. I'll just put link here to check on those videos, but let me just try to solve this problem so quick as possible. Okay, first we have 13, 3, and power 30. Okay, so it's always good to find the how, just to divide the power by 4 to check if, remember 4 was the easiest one to work with. Remember here from other video we talked about I power 4 is equals to 1, of which is the easy one to work with, right? So we always try to make whatever we given to this format, so it's going to equal to, so we do find 28, and how many times do 4 go to 28? On 20 it's go 5 times, and we have 2, and then making it 7 times. So we're going to have I power 4 and 7 outside, right? And that is going to, and then this is going to give you 28. We need 30, so we need I squared. So this 28 plus this give you back 30. Okay, so you can work that out to be what? You can work this one, this is going to be 1 power 7 is always 1, and then I squared, what is I squared? You should remember this from the previous video, and if you've forgotten, remember how we got it. Remember, -1, root of -1 is equals to I, and if I square both sides, and I squared is going to equals to just -1, so it's going to be -1, so this is going to equals to -1. Remember, I do have a 3 here, just forgot about, it's been here, and I still have that 3 here, so this is just literally -3, because now we know that. Let me just do my problem here. This is going to be -3. Let's look at this part now. I power 19. Let's look at this part now. Let me make it red. Let's look at this part, because we have resolved this to this. Let's resolve the I power 19. I power 19, we also have to write it in terms of 4 again. We can have I power 4, and we can put 4, make it 16. Will be, we are on 16, to make it to 19 we need 3, right? So it's going to be point I power 3, and then we know this is going to give us 1. We focus only on this one. What is, remember we have I squared as -1, and what will be I power cube? That is going to be simply as multiplying by I. If you multiply by I, it's going to give us -I. So here we know that we have -I. There was already a negative here. It will make it plus I. If you notice how I'm resolving the problem, the approach I'm taking, I'm looking at it one by one. Let's move to the next one. Now we're moving to 1. We can't do anything about 1. We're just going to record it as it is, this here. So now it is in a good format that we can work with. And then the normal problem that you want to start here, plus I all over minus 1 plus 2I. Then what do you do here? If you're dividing complex numbers, you multiply by a conjugate, of which is going to be minus 1 plus, oh, it's plus, then it should be minus 2I. Because when I keep the value, we do the same thing even on top. Okay, we multiply by this, and okay, then we do the full thing. This multiplied by this one is going to give us a positive 3, and this multiplied with this is going to give us a positive 6I, and the I multiplied by minus 1 is going to give us a minus I, I minus multiplied by a negative 2i is going to give us a negative 2i squared. Okay, all over. Let's look in the denominator. In the denominator, because there's a conjugate, just multiply a first and the first and the first and the first. Yeah, that's how you do it. And because you know that if you're multiplying conjugates in a full method, the middle terms are going to cancel, but you can do it anyway. This by this is going to give us 1. This by that one is going to give us a plus 2i, and this plus this is going to give us a minus 2i. You see what I meant? These are already going away, and we have this and this going to give us a minus 2i squared. So let's work with the like terms now. So here and here we will have 3, and this will give us what? Oh, let me not, before I do 3, let me just do something. I squared is known as, it's minus 1. So you can just know what I squared do. They always disappear and change what is in front of them. Simple as that. And you'll now have 2 plus 3 giving you 5. And we have this and this giving you what? Say it. Plus 5i all over. And on the bottom, this just disappeared. And this again is, what I squared do? Disappear, change what is in front of them. And you'll have this and giving you 3, right? Okay, I made a mistake on my foil somewhere there. I was supposed to say, where is it? I was supposed to say 2, and this one I'm going to give you 4, right? That's the mistake I made. This is going to be, what is it? It's going to give you negative 4. It's going to be negative 4. So from here we already have 1 here waiting for us, and this by this, this by this is going to give us a negative 4. That's why I made a mistake. A negative 4. And what do you know? It should be a negative 4. This here should be negative, and the I squared is always disappear and change what's in front of them and change this back to 4. Then you're going to have 1 plus 4 in the bottom, which is 5, equals to this and this are going to give you 1. This and this are going to give you 1. Then you're going to remain with this, and this is your correct answer. Now we have another problem, and now in this problem they're saying determine the cube root of a complex number z. Z is equals to negative 1. So let me write it in the proper manner that you always say it. It's going to be 0 real part. Oh, we have 0 real part. We have negative real part plus 0 imaginary part. So we can try to plot this looking at it graphically. Maybe it will make sense. So this thing has only a real part, and the real part is what? Is negative 1. So exactly it runs here, just exactly there, lying exactly on the real axis, because on the imaginary part it has 0. So if you want to find the argument of z is going to equal to what? The angle from here to here, and that angle is what? Is pi, or 180, but pi is most preferably. Argument is pi. So, and then what is also, we now have the argument. We also need what? The modulus, or the absolute value. So the absolute value is going to be from here to here, that is distance, right? You can also do the Pythagoras thing if you want to use the traditional way of doing things. It's going to be, this is going to be your the this is the real part, is going to be your a. So it's going to be your a squared plus b squared is equals to z, distance or modulus. So a squared, we know a squared to be 1, negative 1, we square it, plus b, do we have b? B is 0, so squared, all under a root. That can give you the modulus of z, and modulus of z is going to give you what? 1, obviously. So we do have r equals to 1. We do have the argument, so we can write it in the format of um, z is equals to r of which is 1, open cos the argument we just agreed that it is pi, and what else, plus I sine pi again, and then they're saying write the cube root of z, cube root. So we're taking z and we putting him under the cube root of which is equivalent to the saying z is raised to power 1 over 3, right? Okay, so we're going to use De Morgan's law, of which I do have a video where I proved it using mathematical induction. You can just go there, find it on our page. It's on under mathematics for engineers playlist. So this is going to be 1 and power 1 over 3. That's what De Morgan's law say. Okay, and cos whatever you raised with, you're going to multiply your angle with, is going to be cos 1 over 3 pi plus I sine 1 over 3 pi, close. So you can we're looking at z power 1 over 3, or let me not say 1 over 3, let me this side show it the way they wanted it to be, power like this. Okay, and we know that we can raise 1 with anything. It's just going to remain as 1, so we're just going to put 1 here, and here we're going to have cos this one, let me just not write, it's just 1. You remember that I just said it's supposed to be 1 here. We're going to remain with cos pi all over 3 plus I sine pi all over 3. So this is the solution because they wanted it in polar, right? So this is it. But to make sure that we correct, we need to be analytic with our solution. Our angle that we end up, or the argument end up having pi over 3. That is going to be, that is our argument of z under, this is our argument, right? So these arguments happen twice. This is pi over 2. Pi over 3 should be something about here, right? And if it here, it can also happen around here. Okay, so if this is pi over 3, this is going to be 2 pi, is going to be 2 pi minus pi over 2 over 3, I mean. Then we're going to do what, multiply by pi of this here by 3 both here and here, also the denominator, and you're going to have what, 3 dots 2 pi all over 3, then minus pi all over 3. Then you have now common denominator. Then this is 6 pi, this is what, this is 1 pi, you're going to be left with 5 pi. So this is also true. We're not going to have one solution, we have another solution here, of which is going to be z under a cube root cos 5 pi all over 2 plus I sine 5 pi all over, it's not 2, it's 3. Then we're good. Don't forget to thumbs up or comment with any problem that you want us to do. Subscribe, share with your classmates. Thank you.